Hello children, welcome to aimsindia's online classes. In today's video, from mathematics subject, sequences and series topic we are going to continue. In our previous videos, we have learned the concepts of sequences and different types of sequences like finite sequence, infinite sequence, Fibonacci sequence. And the Fibonacci sequence formula, this concept also we have learned already. Our next concept is children regarding series. So here series means a series is something we can obtain from a sequence by adding all the terms together. If you have any sequence, if the sequence has some terms like 1, 3, 5, 7 and so on, if we add all the terms, if they add it together, then that is called as a series. So normally the terms in the sequence are represented by T1, T2, T3, Tn. So for example, suppose we have the sequence like T1, T2, T3 and so on up to Tn. Then the series obtained from this sequence is sum of all the terms. We have to add all the terms together. So T1 plus, T2 plus, T3 plus and so on up to Tn. We have to add all the terms together. And we write Sn, sum of n terms. And the symbol is Sn. And the symbol is Sn. So we represent this series as Sn, which means sum of all terms, all n terms, starting from 1 to n. So this is the sum of n terms. So series means nothing but if we have already a sequence, then all the terms added together is named as series. So actually the idea of sequence and the idea of series are almost related to each other, but there is an important distinction. There is an important difference between them, with which we can separate them into two separate categories. So that is, so for example, if you have a sequence, this one, 1, 2, 3, 4, 5, 6 up to n. So here S1 means, so this is the sequence, S1 means sum of all the terms up to first term, means only one term will be considered in the case of S1. So S1 value equals to 1. So whereas from the same sequence, if they ask us to find out S2, sum of two terms, 1 plus 2, S2 value is 3. Suppose if they ask us to find S3, sum of three terms, 1 plus 2 plus 3, how much? 6. If they ask us to find S4, sum of four terms, 1 plus 2 plus 3 plus 4, how much? 10. Like this, we can calculate the sum up to different numbers and we can name it with separate designation, separate notation. So the series will be infinite or finite or infinite according to the sequence. Basing upon sequence, if it is finite or infinite, series also we can write it as finite series or infinite series. So actually these series are often represented in compact form. Instead of this expanded form, they are often represented in compact form, which is sigma, which is also called as sigma notation. Compact form or sigma notation using the Greek letter sigma. This symbol is read as sigma. So this compact form is represented with the help of sigma, which indicates the summation involved. In the case of terms, sigma indicates summation of the terms. Suppose we have a series A1, A2, A3 and so on up to AN. This expanded form can be written in compact form or sigma notation by using this sigma symbol as sigma of an, means sigma of first term to n terms, the sum, sigma of an. Next note. So here, when the series is used, it refers to the indicated sum, but not exactly the sum itself. So for example, 1 plus 3 plus 5 plus 7 is a finite series with 4 terms. Finite series with 4 terms. When we use the sum of a series, we will mean that the number that results from adding the terms, sum of the series is 16. So if we have only 16, we cannot call 16 as a series. 16 is not the example of series. The sum the direct sum is not the example of series. So 1 plus 3 plus 5 plus 7 is the example of series whose sum is 16. But 16 we cannot tell it is the series. But 1 plus 3 plus 5 plus 7 is a series. That we have to keep in mind. Next one. So we have types of series. We have types of series, different types of series. According to the given sequence, we can divide the series as arithmetic series, geometric series, harmonic series. We can divide the series as arithmetic series, geometric series, harmonic series. Like that, we can define sequences into 3 types of series: arithmetic, geometric, harmonic. So let's start with arithmetic series. So a series with a constant difference between the terms is called arithmetic series. So for example, 2, 5, 8, 11, 14. Suppose we have a sequence like this: 2, 5, 8, 11, 14. So in this sequence, if you see the difference between any 2 terms, 2, 5, difference is 3, 5, 8, difference is 3, 8, 11, difference is 3, 11, 14, difference is 3. So the difference between any 2 terms is constant. The difference between any 2 terms of the given sequence is constant. So this kind of series is known as arithmetic series. So in arithmetic series, the difference will be same between the terms. Suppose if starting term, if we name it as A, if A is the first term, and 2, 5, the difference is 3, 5, 8, difference 3, 8, 11, difference 3. If the common difference, we denote it as D. If the first term is A and common difference is D, then what about second term? If the first term is 2, common difference is 3, how we are getting the second term? 2 plus 3 equal to 5. So second term will be A plus D. What about third term? 5 plus 3 equal to 8. Means in 5 place, in second term place, we are having D, A plus D. For that again D to be added. A plus D plus D, A plus 2D. So in the place of 8, we are having A plus 2D. How we have got 11? 8 plus 3, 11. So A plus 2D plus D. It will become A plus 3D. So this series, because it is having constant difference, because it is an example of arithmetic series, this will be in the form of A plus D plus, A plus 2D plus, A plus 3D, and so on. So not only this sequence, any sequence which is in the form of this form, A a plus d plus a plus 2d plus a plus 3d. This will be an example of arithmetic series where a is considered as first term and in a plus d is considered as common difference. And all the terms can be obtained by adding the common difference to the previous term. So this is about arithmetic series, children. So next we have about geometric series. Suppose if you see this sequence 2, 4, 8, 16, 32, 64. 2 plus 2, 4, 4 plus 2, 6, not 8. So there is no common difference between the terms. But by observing the terms, one pattern will be visible to you. That is 2 into 2 equal to 4, 4 into 2 equal to 8, 8 into 2 equal to 16. 16 2 times 32. 32 means there is with the common term, we are multiplying all the terms except the first term. Any term of the sequence can be obtained by multiplying the previous term with one common number, with one common factor. As we are multiplying, we can call it as a factor, common factor. So 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, 16 2 times 32. So here the common factor is 2. So any sequence, if each term is found by multiplying the previous term by a constant factor, then that sequence is called as geometric sequence, and the sum of the terms in that sequence is called as geometric series. So this sequence has a factor 2 between each number. So each term except the first term is found by multiplying the previous term by 2. So this is an example of geometric series. So if the term we are multiplying, common term we are multiplying is R, and suppose the first term is A, if we have the first term, then second term can be obtained by multiplying the first term with R. Third term can be obtained by multiplying the second term with R. AR into R, AR square. Next term can be obtained by multiplying previous term with R. AR square into R, AR cube. Like that up to AR to the power of n. So this will be the general form of geometric sequence, and the sum A plus AR square plus AR plus AR square plus AR cube and so on AR to the power of n. This summation will be an example of geometric series. So this with what common factor we are multiplying? This is called as common ratio. This is called as common ratio between the terms, and is denoted by the symbol R. So that's why in all the terms we have taken R here. So the common number we are multiplying is called as common ratio. So this is about geometric series. Next, children, we have about harmonic series. So harmonic series means this is the reciprocal of arithmetic series. So normally if you have A, reciprocal of A is 1 by A. If you have A plus D, reciprocal of A plus D is 1 by A plus D. If you have A plus 2D, reciprocal of A plus 2D is 1 by A plus 2D. Like that. So whatever arithmetic sequence we have, for that if we take reciprocal, then it will be equal to harmonic series. Suppose arithmetic series we have in this form: A plus D plus A plus 2D, A plus 3D, and so on, A plus ND. Like this, like this we have arithmetic series. This reciprocal means for each and every term reciprocal we have to take. For A, reciprocal 1 by A. For A plus D, 1 by A plus D. For A plus 2D, 1 by A plus 2D. Because this is equal to reciprocal of arithmetic series. So this is an example of harmonic series, where A is the first term and D is the common difference of arithmetic series, not harmonic series, of arithmetic series. So, like this example, 1 by 1 plus 1 by 2 plus 1 by 3. If you take the reciprocals, 1 by 1 reciprocal is 1, 1 by 2 reciprocal is 2 by 1, 3 by 1 reciprocal is 3 by 1, which is nothing but 1 comma 2 comma 3, which is an example of arithmetic series, where each term can be obtained by adding plus 1 to the previous term. So for finding harmonic series, for finding the sum of harmonic series, there is no separate formula. So first, for finding sum of harmonic series, first we have to convert into arithmetic series, and we have to find the sum of arithmetic series. Then finally, we have to take the reciprocal of that sum. That will be the sum of harmonic series. So no separate formulas are involved in the case of harmonic series. We have to convert into arithmetic series. We have to find all our whatever requirements we have. Then we have to take their reciprocals. Okay. Next one. Suppose let the sequence AN. Let the sequence AN is defined as follows. A1 equal to 1 and AN equal to AN minus 1 plus 2 and AN equal to AN minus 1 plus 2, where for N, what they have given here, N something they have given here. Let's see later. So we have A1 first term, we have A1 value 1, and we have AN value AN minus 1 plus 2. Means any n term can be obtained by adding its previous term to 2. Previous term to 2. Suppose AN equal to AN minus 1 plus 2 means, suppose we have A2. Suppose if we take A2, it will become A2 minus 1 plus 2 or A1 plus 2. So according to this nth term formula, any term we can find by adding plus 2 to its previous term. So A1 equal to 1, A2 equal to A1 plus 2, which is equal to 3, A3 equal to 3 plus 2, 5, A4 equal to 5 plus 2, 7, like that, and so on. So first 5 terms of the sequence are 1, 3, 5, 7, 9. So corresponding series is 1, 3, 5, 7, 9. Corresponding sum is sigma of A5. Sigma of A5, which is equal to 1 plus 3, 4 plus 5, 9 plus 7, 16 plus 9, 25. 25. We have got 25. This is the sum of arithmetic series. If they ask sum of harmonic series, it will be 1 by 25. It will be 1 by 25. So first we have to find the sum of arithmetic series. Then we have to take the reciprocal of it. Then it will become sum of harmonic series. Okay, children, that's all for today. Remaining topics we can learn in our next video. So thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. You can also visit our website, children, www.aimstoday.in, for information regarding online classes, quizzes, worksheets, activities, English classes, coding skills. Thank you, children. Have a good day.